Limits can also help us understand the role in which infinity plays with respect to certain functions, such as this next example. We have the rational function 1 over x minus 2. So let's see what happens as the limit as x approaches 2 from the left and as x approaches 2 from the right. So I'll plug in each one of these values, 1.9, 1.99, because I'm looking for values that are close to but yet smaller than 2. So when we plug them into our equation, we end up with negative 10, negative 100, negative 1,000, negative 10,000. Well, they're sure not all going to the same number, that's for sure. But let's see what happens when we approach 2 from the right. So numbers that are slightly larger than 2, and we're plugging them in. We end up with 10, 100, 1,000, and 10,000. Well, this makes sense as we're seeing what happens at 2 here. We see then that as x is approaching 2 from the left, so as we're approaching 2 from the left, our function is decreasing without bound, meaning it's not going to stop. Therefore, we can say that the limit as x is approaching 2 from the left is negative infinity. Further, we can see that as x approaches 2 from the right, so as we're coming to the right and we're approaching 2, f of x is increasing, so our y values are increasing without bound. So this time, this limit is going to infinity. However, since the left hand and our right hand limits are not equal and certainly not finite, meaning they don't end, the limit does not exist at 2. Sometimes we need to find limits as inputs approach positive or negative infinity. In such cases, we are finding limits of infinity. Such a limit is expressed as finding the limit as x is approaching infinity, or finding the limit as x is approaching negative infinity. Such as our next example, example 5. Let's let f of x equal 1 over x minus 3. Let's find the limit as x is approaching infinity and negative infinity. So I'm going to choose values of x that are going to infinity and plugging them in. When I do, we get some pretty tiny numbers. So it looks like we're approaching 0. Further, as x is approaching negative infinity, we can choose numbers and plugging them in. We also see that it is approaching 0 as well. So as x is approaching positive infinity, the value of f of x is approaching 0. Further, as x is decreasing toward negative infinity, f of x is approaching 0 as well. Therefore, we can say that the limit as x approaches infinity is 0, and the limit of as x approaches negative infinity is also 0. Let's consider this example, 1 over x minus 2 plus 3. Let's find the limit as x is approaching 3. So we want to find the limit as x is approaching 3 from the left and from the right. So we want values, pause for a moment. Okay, we're looking for values that are slightly less than 3 and slightly greater than 3. We may predict already that as x is approaching 3, we're probably going to be pretty close to 4. Let's see what happens. So when I plug them in, we get 4.1, 4.0101, 4.001. Now let's see what happens as we approach 3 from the right-hand side. When we plug in the values, we get 3.9, 3.99, 3.999. Therefore, because we are approaching 4 from both the left-hand side and the right-hand side, we can say that the limit as x is approaching 3 is equal to 4. Let's find the limit as x is approaching 2. So what happens as x is approaching 2 from the left and from the right? You may already have a gut instinct that the limit does not exist, but let's prove it. So values that are slightly less than 2 when we plug them in are -7, -97, -997. So no pattern. Similarly, what if we approach 2 from the right-hand side? So as we approach 2 from the right-hand side, it looks like we're going to get large numbers, 13, 103, and 1003. Since the limit as we're approaching 2 from the left and from the right are not the same, the limit does not exist at 2. And finally, let's find the limit as x is approaching infinity. So I'm going to choose values where we're approaching infinity quite rapidly, such as 10, 100, and 1,000. When I plug them in, we get 3.125, 3, and 3. We can say then that as x is approaching infinity, which we can see, we are getting very close to 3 here. And that concludes our lesson on limits, a numerical and graphical approach.